here.
Oh, there you go.
Yeah, there you go.
I think so much better of you now.
Happy, happy, happy.
Nice one, yeah.
Let's see. Let's go back to filters. None. Distraction. I have a question. I have several, but I hope an easy question. If Mass Save has proposed putting insulation in my attic, and I get this benefit from Mass Save for that insulation installation, can I say I want the benefit, but I want to put it in my basement instead of in my attic?
You can try, Katie. I've found that Mass Save contractors can be quite rigid because they get paid like a fixed amount of money. So they really want to get in and out as fast as they possibly can. And often that means they will come in and just put blown in cellulose in your attic and leave. Maybe there's a couple other things, but not much more. So you often have to like sway them to go beyond that. Now they often will, but you have to work at it. You can't just sort of expect them to do everything. There she is, it's Cindy.
Hi, sorry, I was having technical difficulty. Hello.
Welcome to the club.
But I'll say one more thing for Katie on Mass Save, having deal with it, and I'm supposed to get some work done soon myself. Unless it depends whether you're doing if you're doing like Clear Result where somebody else did the audit and then they have a contractor come in. These contractors can't do anything other than what's specified by the audit and the sort of the work order, so to speak, so that you'd have to get it changed ahead of time through whoever did the original audit, so that they can do that, because the contractors are supposed to be audited against what they do, and so their hands are tied if they don't have that as part of the work order, so to speak.
Okay.
Will they do your attic and your basement?
Yes, they will.
They told me they don't, in terms of the audit itself. So when they said they still leave the basement as far as installation.
Hey, Katie, we're getting a lot of echo on Nicola's, on yours as well as yours, Katie.
Yours too.
Does someone have a cell phone open or something?
No, I haven't.
Right. They will do, I mean, I'm supposed to get a little bit of work in my basement as well as in the attic, and they go around the doors. They're supposed to do weather stripping on the doors.
That they'll do.
And they're doing a little around the sill in the basement. So there's a range of things in the work order that I have.
Okay.
Okay, guys, let's get started tonight so we don't run late. Are you hearing an echo?
Yes, yes, yes.
So somebody's got two.
Did this start when I joined, just out of curiosity?
Yeah.
I told you I was having technical difficulties. Let me try to, I'm going to log out and I'm going to go to a different computer and I'll.
It's not happening now. It's not happening now. I wouldn't even bother.
Nicole, could you say something?
Hi, everybody.
Oh, okay, it's goes on. Katie, can you say something?
Go.
Okay, it's gone.
Keep talking, Katie.
Carry on and see how it goes.
Okay.
So Katie, there's an echo on yours for some reason. Anyway, let's carry on and see how it goes.
You have a echo now, which is hard.
So I think what's happening is
We're getting feedback from Katie's system, I think.
from whose system?
Sounded like it might be Katie's. Okay, try now because she's muted.
Okay, can you hear me now?
Mm-hmm.
Is there an echo?
Yeah,
I can't hear one.
a little bit.
Echo. Okay. All right. Well, let's try it. So Cindy, you logged out and came back in, right?
I did not, but I can.
I think let's try it and see. So let me just the one admin thing. So you may notice Colleen is not here, and the reason Colleen is not here is because she's dropped out. The reason she's dropped out is because she's a renter, not a homeowner, and she was finding so much of the work was based on home ownership. It wasn't very relevant to her, And I pointed out to her that most of her clients are going to be homeowners, not renters. But she's had a lot of stuff happen in her life recently as well. She's in the hospital for 2 nights for something. I don't know what it was, but something that was put her in the hospital for 2 nights. And she's also got 2 young kids. I think are demanding on her time. So Colleen's not here. I've offered to try to create a program for renters. So I do think there's a lot of renters out there, and there's an element of this program, not all of them, but elements of this would be good for renters too. But anyway, that's sort of ongoing on the side. Now the other thing is, so tonight, so I call this session putting it all together. Okay, we've done all the pieces now. We did 2 lessons on the Fab Four, on the technologies, how they all work. We did 1 on financial analysis, discounted cash flows, net present values, IRRs, etc. We did 1 on energy modeling and cost estimations for the different elements of the Fab Four. Brett did this with consulting skills last year, needs versus concerns, advocacy and inquiry. So this one is putting it all together. Okay, so what we're going to do is go through. I've got 3 examples. I'm not sure we're going to get through all 3. But we've got 3 examples of the outputs you will get when you consult with clients.
David, just a point. Maybe everybody could go on mute because I'm getting a lot of feedback. And if everybody's on mute,
right.
it's you're the
Try
problem.
everyone on mute. Is that better? Okay, now I can't hear you, so you've got to really exaggerate the nod and nose and like, right? So, okay, that's good. I can. I've got no echo, but I can't hear you all. So press the space bar, and you can then talk for the time when your space bar is down. That's a good way of just like unmuting yourself to say something. Okay.
David, I have a question.
Yeah.
In the document titled Cost Estimates and Subsidies, on page 8, it says the ITC is also available for geothermal heat pump systems, but it is not available for air-sourced heat pumps?
That is correct.
Is that correct?
Yeah, that is correct. Yeah. It is there for geothermal. It does bring the cost of geothermal down a bit, but not enough to make it really cost competitive with air-sourced heat pumps. Unless you've got a friend in the trade. If you've got a cousin or something who does drilling of wells, and you can get your wells drilled cheap, then geothermal makes sense. But it's the upfront cost of the wells that makes it so expensive. But if you've got a way to like get your wells done cheap, then it can start to make sense if you've got solar panels as well to generate all the electricity.
So for our purposes, the investment tax credit is not usable.
I think only under very rare circumstances. I think for most people, it's not usable. You're right, Scott. It's too expensive for most people. Katie, do you have a question?
Yeah.
I had a question because I was on a call earlier today with some people who have heat pumps who said that you really don't need the backup furnace at all, period, because things have gotten better. Where do you stand on that? Because we've been talking differently.
So it's an unresolved question at this point, Fred. I gave a webinar a couple of weeks ago, and there was a Mitsubishi engineer on it who took strong offense to my statements about the performance of his products and the Bosch products as well at my house. And he claimed, so I spent an hour on the phone with him afterwards, a separate conversation. And he claimed that Mitsubishi has had lots of experience, lots of homeowners who do have year-round heating of their houses in New England with only heat pumps. And I said, well, that's not my experience. And what I talk about on the webinar is my experience. I don't talk about your experience. I talk about my experience. And I don't try to extrapolate from where I am to where everyone else is. But anyway, we had kind of a tough discussion about it. But in the end, I said, okay, well, I'm very open-minded. I'm happy to be persuaded, but I need evidence. I'm not going to be persuaded to change my mind because I've got experience, and my experience is matched by other Heat Smart Alliance coaches and published academic papers by independent professors at universities who studied heat pumps in New England and measured their efficiency and stuff. So what I said to him is, I'll give you 2 options. One is publish the data. Don't give me anecdotes, but publish the data in a peer-reviewed academic journal with an independent researcher managing the research, and show me the data. and do it on a sample size, not anecdotes, but show, 25, 30, 40, 50, 100 houses, and show me the results. That's one way you can persuade me. The other way you can persuade me is come to my house. It's our rental property where we have the Mitsubishi pumps with the installer, Rodenheiser, and see if he blamed everything on the installers. So I said, well, look, Rodenheiser is a Mitsubishi Diamond Elite installer, which is their top ranked installer. I've used them twice. I've recommended them to my clients. I think Rodenheiser is very good. They're expensive, but they're very good. And every time I've met their electricians and their plumbers and stuff, I've been impressed with the technical skills they've got. So it's like, I don't have any complaints about these guys. But if you want to come to my rental property with Rodenheiser and figure out whether the design is wrong or whether it was installed wrong, please go ahead. So next week they are coming to do that. So what was it? So that's why I say, Fred, to me, the jury's out. I'm happy to be persuaded. I'm not stuck in the mud. If you can show me evidence that trumps the evidence I've got, I'll change my mind. I'm not changing my mind because one engineer gives me anecdotes and he works for the company whose product he's selling. It's not like a match of the quality of the data set. I've got data up here and his data's down here. It's biased, it's anecdotal, not statistically rigorous. So anyway, so that's where we are, Fred.
I'm just saying the anecdotal data that I got from two people who I know who have heat pumps was simply that, no, you don't need a furnace backup.
Right.
And I was just interested because as coaches, we should be able to answer that question.
Yeah, and I hope that this work with Mitsubishi will answer that question, because what I suspect is the answer, Fred, is that under some circumstances they can work, but under other circumstances they don't. And right now I don't know what those circumstances are. But that's what I think the answer is. Yes, in some places, but no in others. And I just don't know how to evaluate it in advance of doing it. So right now, I'm much more cautious and I say, let's keep your furnace for now. And if after 2 or 3 winters, you don't need it, well, then take it out. But taking it out up front is kind of risky. I think you might end up being cold in the wintertime.
Well, don't most of these heat pump air handlers have supplemental elements in them?
They
And
do.
why would they do that if they didn't need it?
These are the sort of points I was
Give me a
making,
break.
Scott. And I was also, he also made a point, kind of an in passing comment saying, we Mitsubishi do not recommend setbacks. Setbacks is where you put the temperature lower at night. So you may have it at 70 degrees during the day, you set it back to 60 degrees at night.
Because it takes too long to get up there.
Right. So you're right, Scott. That's why they recommend it. That is increasing your heating bill so they don't get complaining customers. So that to me says their attitude is, we don't care what you're spending as long as you don't complain about our products. Well, I think that's what's going on here. With electric backup heating, you can keep any house warm, but it's going to cost you a fortune. So this is where these are some of the areas where I think there's sort of room for them to be saying one thing, but finding out something different in practice. Mitsubishi never mentions cost of heating. They just talk about the COP and how wonderful their products are, but they don't give you any financial data on money saved. Anyway, let me suggest we get going, or we'll never make it.
I have a question. It's quick. We have wells and septics in Sherburne. My neighbor just had to have a new well dug.
Yeah.
Were she to decide she wanted geothermal at the same time as she had her well dug, would it no longer be prohibitive, or is the cost of getting the whole system together prohibitive?
So I don't really know the answer, Katie, because I've not done it, and I don't know anyone who has done it. I'd be very interested to find out, though, because I've been talking with a very, very good HVAC guy who's designing a system for our rental house, and not the one where Mitsubishi's coming back. We've got a second rental house that's where we haven't done any work on it yet. I'm sorry, what's my train of thought there? Where are we going, Katie?
You have an engineer designing something for your rental
that's
house.
Right. That's right. And he has also mentioned this, that you can put in a geothermal heat pump driven off the well pump. Now, I'm skeptical because I just don't think you can get enough water out of well pumps that we have to feed a geothermal system. But like, I'm open to persuasion. And maybe if you put in, when you're doing it from the start, maybe you put in like a 8-inch diameter hole rather than a 4-inch diameter hole, get yourself much more water flow if your water supply can actually bear it. And I think most houses in Dover and Sherburne, they're not going to have the water quantity to be able to do a well and a geothermal at the same time. But who knows? I mean, I think this is a great question. I don't know the answer. I'd be very interested to find out, because if that is true, that you can do a well and a geothermal at the same time, that really reduces the cost of the geothermal, and that would start to make it cost competitive with air source heat pumps. And the great thing about geothermal is because the groundwater is the same temperature year round, you can heat throughout the winter time. So you don't have the issue of keeping a backup furnace, because you know you're going to get enough heat in the middle of winter. So I'd be very interested to find out, Katie, how this goes. So just let me know.
I think, it could come up in Sherburne where it might
Yeah.
not other places.
Yeah, I'm sure it will. So let's just talk about what we're going to do tonight. So we talked about putting it all together. So I sent around Michael's house data this afternoon. Did everyone get it? Right. Okay. Did you all print it out? Because it's going to be hard viewing it on screen if you're trying to do Zoom at the same time. So what I thought we'd do is just go through this. This is basically the data you will receive as a coach, after graduation. So you work with the client. You send them the spreadsheet. They fill out the spreadsheet. You'll probably have to go back and forth with them a bit to make sure it's filled out properly. So you'll have the client data, and then I will run the model for you until such point as I can make it available. But right now it's not something that anybody other than me can really use. And I'll give you the results of that. So the two things we got for Michael is Michael's questionnaire filled out, and then the results of the analysis using the energy model. So what I'd like to do is just go through Michael's client questionnaire and just get your feedback and comments on it. And what I'm interested in here is, what do you think is sort of noteworthy? What is interesting? What is unusual? What might make you think twice? What is sort of things that stand out? So let's just start with Michael's questionnaire. Looks sort of like this, and just as you go down this, what sort of things are coming up and making you notice as you go down his questionnaire?
Well, what I noticed was the 4,460 square feet.
Yeah, so pretty big house.
I don't think that's right, because we're talking about the square footage that's inside the envelope, the conditioned air envelope. In this case,
This is an outside dimension that the town uses.
regardless,
Yeah,
I think it's closer to 3,000, because your basement's not heated, right?
Right.
And basically you're 25 by 60, 27 by 60 times 2.
But there's a 25 by about 27 L. There's an L, it's L-shaped. It's not just one long.
Okay, I'm just going by what you filled out on the sheet.
Yeah, no, I'm trying to figure out how this thing.
So if you include the square footage of the basement, then you'd come up with about that square footage, the 4,460. But your basement's not conditioned.
Well,
So I think
it's half conditioned, but whatever.
But your logic is impeccable, Scott. That's exactly how to think about it. Just so you know, in the energy model, I put in the dimensions of the basement, the dimensions of the first floor, the dimensions of the second floor, and only if the basement is heated is it included in the heating in the square footage I use in the model for calculating dollars per square foot and things like that. So your logic is absolutely impeccable, Scott, but it's actually taken account of in the model. I don't just take what someone puts in as their square footage. I do it floor by floor based off the conditioned space.
Okay.
But what's missing here, just so you know, is that the question is how this works for a house that's not a rectangle. My house is not a rectangle.
Yes.
Well, a square foot is a square foot is a square foot.
I know, but when you're looking at all those other numbers that you're comparing, it doesn't show the fact that it's L-shaped, that there's a 25 by 60, and then there's a 25 by about 27 L patched on sort of a short leg off to the side.
All right.
And that 25 by 25 is 600 right there. And you double that, it's 2 stories. And so there's another 1,200 square feet right there. So, or it's 24 by 24, whatever. There's another 1,000 square feet in this other part of the L that goes on here. So who knows how that, and I remember I thought I had put that on the side. Maybe I forgot to add, or whether I thought I put it in a note in a separate column that's not showing here, that the house is L-shaped somewhere. But whatever, but that's an issue of just how you get this.
Okay, so I think one of the things that we're sort of noticing already is there's a lot can be lost in translation in just gathering the data. And we haven't even got to kilowatts and kilowatt hours yet, or thousands of cubic feet of natural gas versus therms of natural gas. But you're starting to see already there's a lot of back and forth to get this right. Now, let's just keep going so we don't spend all night on one thing. The next thing I notice is the existing solar panel array. And
which isn't hooked up.
It's hooked up now. It just got a week ago.
All right.
Generating 30 kilowatt hours a day.
Excellent.
All right, times 20 cents.
Mhm.
This was something that made me sit up and think about it, because I knew that my model did not have the existing solar panel array built in. So I actually had to create a new part of the model, especially to do with Michael's house. But don't worry, Nicole, I have to do the same thing for your house. Your house has a swimming pool, and I did not have the ability to subtract out the swimming pool. So that I do now, thanks to your house, which was very useful when I came to do Cindy's house, because Cindy's house has a swimming pool too, right, Cindy?
Cindy.
She does have a pool. It's a very nice pool.
Yes,
Right.
it is a nice pool. I've been there.
Yes, I have a pool.
So these are the sort of things that can throw you off. If someone already has, so now I have these built into the models, it's a lot easier to accommodate it. But things like this, which are unusual, you need to be paying attention to, because otherwise it could really throw off your calculations of the electricity used by the house, because the electricity used by the pool, for instance, and any fuel used by the pool has to be subtracted out to get the energy used by the house. Okay, now for you, all you need to do is be aware of it, because remember, I'm going to be doing the energy modeling for the, I don't know, at least the next little while. So I need to be aware of those things. So if the question is filled out properly, I'll be made aware of it. But it's something that you would need to make sure you've got right with the client. That if there is a pool, you need to know about it. If there is an existing solar panel array, you need to know about it. Otherwise, the model is going to be off, and then the financial results will be off as well. Okay, anything else that jumps out at people as you go down the list?
Michael, I think you said that you were going to have insulation blown into the attic for nothing.
Yes. It's part of the Mass Save deal that came out last year that I got into.
So there is no investment there.
Right. That one's a no-brainer.
Yeah, and that will be in most cases. What you'll see of all three of the houses tonight is all of them are under insulated, even the ones that might appear to be fairly well insulated. There's still money to be saved by adding insulation. And the way I do it in the models I calculate is as though you went to Home Depot and bought it. But if you can get it for Mass Save, it's going to be free or very much cheaper than even that. So it's in all three cases tonight, adding insulation was very good value for money for everyone.
Yeah, but in this case, since he's not making an investment, he's missing out on the net present value of $42,000.
He's not missing out on the net present value of it. It's just the investment up front is zero. So
Right. No, I'm going by the sheet that right at the top, 42 grand. NPV.
Yeah, you're getting ahead of us.
I'm not missing out on it. I'm getting even more.
You're getting, yeah, it's an even better deal. It's an even better deal.
No, net present value has all the benefits in it, so I'm not missing out.
Exactly. So what else jumps out at you as you go down the list here?
He doesn't have any air conditioning.
Yeah, very, very good point. No air conditioning. So that's something that we'll come back to later on with the recommendations. But That's unusual. It's unusual.
So
for air
you
conditioning.
you
And
spend
then
the
therefore-
summer up to here in Farm Pond? Is that what you do?
No, we partially did 3-foot eaves so that in the summertime, the second floor is somewhat shadowed because of 3-foot eaves was part of the original design of the house. And we tried to insulate the house a lot for when it was done. At the time, it was considered a house there. And it was also the choice of windows. Yeah, although the solar heat gain's interesting. Like today, my office, which has mostly windows, got to 69 degrees with the sun.
With the sun, yeah.
Even though it was warm today, but
Michael, did you build your house?
yes.
Okay.
We knocked down the old one and redid it ourselves about 15 or so years. Well, took years, but so yes, but we decided not to do air conditioning at the time. We thought we could avoid it, and it isn't. I open up 20 windows at night when it gets cold, and I close them down in the morning when it gets in the summertime. That's what I do to ventilate the house.
And your thermostat set temperature is 63? Is that 65?
5 during the day,
Oh,
60 at night.
Depends what rows. We have 7 zones. We put in a lot of zones, 7 zones. So for example, tonight, since there's only 2 of us now in the house, each of us have our home offices and they're heated to who knows what, 65 or something like that. In other parts of the house, there's rooms like my kid's bedroom's at 51. She's not here. There's another sort of like living playroom space that's at 51 degrees. And so the house is heated very unevenly depending on occupancy. So
That's very efficient. Very, very good use of the
Oh,
fuel.
yeah.
The heat
no,
will-
we spent a lot of time figuring out how many I mean, it was worth the cost to put in a lot more zones and run the extra piping.
Yeah.
So that in the long term, we had control over a lot of spaces.
Okay, so I agree. That was both the thermostat temperatures was set fairly low. Our house, reading these, by the way, several of you have quite low thermostat settings. I feel so wasteful now. Our thermostat is set to 70 degrees during the day, and it goes down to about 65 at night. So our house is kept much warmer than yours. If I didn't, by the way, I'd be divorced now. But that's what it takes to keep our marriage together.
Right. I might be divorced if I went like your style. So
Mine as well.
Is this going
The other
down?
thing I notice is you're using dense packed cellulose in the walls.
yes. we
That's
put a lot-
unusual.
Yeah, no, that was the best I could find. I wanted the foam, the blown in isonine or foam, but it was too expensive back then, at least for my budget. And so the dense packed wet cellulose, as they called it back then, doesn't settle and it was good. I used it a lot. I mean, I have 2x6 walls.
Yeah,
When we
that
did
was
the
something
house, we
I
did-
noticed. That's very unusual, 2x6 walls. Just so you know, I've never come across that before.
Oh, really? I thought it was, I would like to think it's the norm, but we did 2x6 and we tried to minimize back then even, you called it advanced framing. You tried to minimize the amount of wood so you had more insulation because the wood is not a good insulator. So you would try to minimize the number of studs, but we didn't go to 24-inch distance between the studs, even though we talked about it at the time, but it's still by 16. So we did that. So we did, and it's also tightens up the house a lot with the wet cellulose.
Yeah.
And it works well. We did it even, you do it in interior walls too for soundproofing, like between bathrooms and other rooms and stuff like that. It's a great thing.
So just so you know, in my experience, it is unusual to have 6-inch walls. It's a good thing, but it's unusual. And
It is now. It was common in more severe climates like Chicago.
yeah,
Before polyurethane foam the price came down on it because now you can get a much R value in a 3.5-inch wall as you could in a 5.5-inch wall that's insulated with fiberglass.
I would also say that it's been my experience in my lifetime that 2x6 construction is common if you're going to do a house with all electric, like the radiant electric, because they're trying to pack as much insulation in as they can to keep down the cost of the electric.
Yeah.
And I don't know what the cost is today. If you did 2x4 and you put 2 inches of rigid on the outside and things like that, that was kind of, we didn't want to do. I guess I got to go fight with my.
We're gonna spend
Yeah,
all
go
night
on.
on Michael's house. We'll just keep going. So the other things that popped out to me was the 15-year-old fridge. 15 years old is about kind of the age where it starts to make economic sense to replace it. Probably not a slam dunk, but at 20 years or 25 years, a new fridge is going to pay for itself in just 18 months on the electric bill savings alone, because old fridges are very inefficient. This is why I asked the question about the appliances. It's often a very easy piece of low-hanging ripe fruit if the fridge and the freezer are more than about 15 years old.
Even if they were Energy Star at the time.
Yeah, Energy Star has got much more demanding over time. Now, because it was a decent one 15 years ago, and it's 15 years, not 20, 25 years, I would look at the electricity usage. It's usually posted on the inside of the refrigerator, and then compare that to the electricity usage of a new one. But I replaced a 20-year-old fridge at our rental property, and it paid with a new Lucky Gold Star one, LG, and it paid. That was like $1,500 for the new refrigerator. It paid for itself in 18 months on the electric bill savings alone. So
Guess I'll have to go compare the new standard.
What is the comparison, or not comparison, but what is the like, so you're getting rid of a fridge and you're just dumping it into a dump, or does somebody pick it apart and take all the metals and whatever they can recycle off the fridge? Like, I just, in my mind, I'm thinking, okay, well, how green is that? Like, you're just taking the fridge and trashing it to put in something that's more energy efficient, but what happens to that? Does it just go to the, landfill? Or is somebody picking that apart and trying to get every valuable thing off of it?
The refrigerant has to be captured and pumped into a container for recycling or incineration. And then after that, a scrapper would take that refrigerator and send it through an automotive shredder.
An automotive shredder?
Yeah.
I don't know what that is.
They'll get the metal.
It's a device that shreds cars.
Okay.
It can shred.
It's
really-
basically the metal will get recycled.
Yeah.
because
Okay.
They'll use a
So then
magnet,
it's-
whatever
okay.
else, and other things to separate out the metal. So it will get recycled. The plastics, unfortunately, is some bit of plastic.
That goes in landfill.
Mhm.
Um,
Thank you.
It's called fluff.
Okay, and then the last thing that I really noticed on Michael's is he wants to buy an EV. So buying an EV or thinking you're going to buy an EV in the future means you need more solar panels to be able to charge it cheaply. Or certainly it's a big advantage, a big cost advantage to be able to generate your own power and charge your electric vehicle. So in the model, I allow for, if someone says I want a new one, I allow for that, and that increases the size of the array needed for that house. So if someone says they want an electric vehicle in the future, that's accommodated, is built into the calculations in the model. Okay, all right, so that's Michael's questionnaire. Now turn to Michael's benchmarking page, which is this one. All the graphs. So just sort of eyeball this and look down the list and say, does anything stand out as being a long way from the benchmark? The benchmark is the blue one, and the red is Michael's house. What sort of things jump out at you from this?
The draftiness.
Yeah, the draftiness is very much off scale. Now there should be a label on that small blue bar in the middle. That small blue bar is passive house standard air infiltration, which is unbelievably tight. So that is sort of like essentially zero. Tight new construction is if you built a new house today and it was well built and well insulated and well air sealed, it would have that level of air changes per hour. And Michael's house is significantly larger than that. Now that's because Michael's house, even though it was 1980, Michael, is that right?
No, 2004.
2004. So it's it's not that old, but
Yeah,
it's
but those numbers came from the blower door data.
yes, correct. And that's unusual to have someone with a blower door test. If they do have a blower door test, I can put that in as a number, and it calculates these things. If the person does not have a blower door test, then I just kind of estimate it based largely off the age of the house. Because the older the house is, the more likely it is to be drafty. And asking qualitative questions like, is it drafty? Do you feel drafts if you're sitting at the kitchen table? Because if people do, and you're picking up that qualitative stuff, then I tend to bump up the draftiness of the house. But you can see
based on Michael's description, it sounds to me like his house is pretty tight.
Not based off his blower door test.
Yeah, maybe something's wrong there with the data.
Yeah, because when I normalized it against, I guess I sent you in a separate email. Right, part of the reason my house leaked, the blower door test, because I guess it's a question of what you put in there in terms of the volume of the house is one issue. If you put in 3,600 square feet, then as the square footage and you calculated the volume or from that, then this is going to give you a much higher. I mean, I'm not sure it's worth the time to proof it, but if you put in a much higher number, then because when I normalized it, because you can normalize it based on your volume or the surface area, and it didn't get that it was that far off, but maybe it's not worth the time now to fine tune it. My house is also could be considered drafty because I have a tremendous number of double hung windows.
I was going to say the amount of windows you have, 66. That's stuck.
That's
What
a lot
stuck
of
out to me.
Yeah.
Right.
That's a lot.
Yes. Oh no, it's a phenomenal number.
So I suspect that the blower door test is right here, and that Michael's house is draftier than he thinks it is.
Well, I'd like to know what you put in.
Especially when he opens all the windows.
Yeah, right. Well, there you go. Right. He's already told us he leaves the house
Every night.
Right, every night. So anyway, so
summer and winter, I do that. Right.
but overall, I think other than the draftiness, Michael's house is actually pretty close to the benchmarks. It's not much better. It's not much worse. It's kind of about average, about what you'd expect. But the draftiness is definitely significantly more than you'd expect. So that will come back when we look at the recommendations. So let's turn over now to the recommendations page.
Can I still ask you what square footage you put in, or we could just do that another time?
Not without me having access to the model, because I calculate it for each floor. So I can't remember how much is in the model. I only have the results page here, not the.
Okay, fine. Because that's not just all because how it is, but we can do that separately.
Yeah, but let me know afterwards, and I'll tell you what I put in.
Good. Okay, go on.
So now my results here has all of my commentary here. These are my recommendations to Michael, which I did not send you. So we are here going to
pay for that
recommendations. So, coaches, over to you. What do you make of Michael's? Let's start with the insulation. What are your observations about the insulation? And now I gave you the net present value here. You can see the investment necessary if you were paying for it, Michael, not if you're getting Mass Save to do it. It's about $5,000, which is actually quite a lot for insulation. But it's going to save them $2,000 a year, massive net present value, and the IRR is also massive. So Michael's going to save a lot of money just by doing some insulation. And
he's not even paying for it.
Right.
Man,
I already paid for it through my electric bill.
Yes, exactly. Yes, you've already paid for it.
Okay.
So even if Michael were paying for it, it's still an excellent investment. Just increasing the insulation in the attic with blown-in fiberglass, so blown-in cellulose or fiberglass will be fine, and also the ceiling of the basement. There's the one part of it is insulated, right, Michael? But the other part is not.
No, it's all somewhat insulated. That's why I have a question about whether that's worth doing. But it depends whether we have the time now or whether we should just keep going.
Let's keep going to make sure we get through this example, so you can get more of a feel of the scope of sort of a normal house when you analyze it. Excuse me. Now Michael has he has insulated his hot water pipes in the basement. Oh, sorry. I'm getting into my conclusion. So just looking at this with only the numbers, do you have any observations or comments on what Michael should be doing?
He should do something about his hot water.
What's up with this hot water?
Well, it looks like the net present value is positive, whereas the heat pump is all in the negative.
So just talk through that, Scott. Talk through both the heat pump hot water tank and the heat pump space heating. What are you seeing there? What are the numbers telling you, Scott?
Well, if he replaces his current hot water, domestic hot water system with a hybrid unit, and he's powering it with utility electric, the NPV would be $1,100.
Yep.
And if he's powering with his solar panels, the NPV would be about $4,300. So there's an opportunity.
Yeah, so I agree. So the heat pump hot water tank is pretty much a slam dunk. It's even if you're paying utility rates, it's going to make a positive financial return for you and a 12% IRR, which is very good. Going to pay for itself in 9 years. But if you're going to put some solar panels on to increase the amount of solar electricity so that you can generate enough to run the heat pump, then it could save you about $4,000 over the course of the investment with an IRR of 38%, which is outstanding. So I agree with you, Scott. That's one of the recommendations would come really right out on top is adding a heat pump hot water tank.
And Michael,
And a side benefit of that would be that I noticed elsewhere on Michael's questionnaire that he said it was, he runs a humidifier. So a side benefit would be that it would take the humidity out of the basement.
Yep, that's
by using the heat, the hot water, the domestic hot water heat pump
hot water tank. Yeah.
Yeah, heat pump hot water tank.
And when I went through Michael's questionnaire, I flagged that area where he's talking about sometimes you get some dampness in the basement, because that's immediately telling me, hey, he's either wasting energy by running a dehumidifier or he's got problems with mold and stuff growing in the basement. So if we can put in a heat pump hot water tank, in addition to the financial savings here, it's going to dehumidify the basement for free. So at the very least, he's going to save the money he's currently spending on running that dehumidifier. At the very
The other thing, well, and this came from when I met with Michael in the breakout room, is that I think, Michael, you said that you were allowing your sister to use some of your credits. Is that right?
Oh, yeah.
So
I oversized the system.
What?
I oversized my solar system.
Right. So then he could fuel that hot water heat pump right off of his current array.
Yep. Very good observation, Cindy. Yep. There's some upside there that would allow Michael to easily fuel, as you said, to power this hot water heat pump hot water tank without the need to add additional solar panels.
I'll just give you the sort of as a client, I would sit there and say, I mean, a dehumidifier is probably not going to help me as much because of the way the basement's set up. You'll get into that reality of it's in a utility room on the that's sort of closed off. It's one part of the basement that's somewhat closed off from the main part of the basement that where sometimes there's a little dampness feel, and I could get a little bit of mold if I don't dehumidify. So it's one of those practical air circulation issues. It's like I'd have to go run a fan to circulate the air that's drier in the utility room where the heat pump hot water heater would be versus where the main part of the basement is.
Is there a door between the two rooms, Michael?
What?
Is there a door between the two rooms?
There is a door that I could leave open, but I don't know how well the air will circulate. Because it's at the far end of 60 feet, basically, where the humidifier is 50 feet away from where the hot water heater is.
Yeah, so my suggestion would be to try it and see.
Yeah.
I mean, your worst case scenario is keep the dehumidifier at the other end of the basement.
No, and hopefully it would be working less. But no, it seems to make sense. So how do you calculate how much is spent on hot water in this? I guess.
Good question.
You do the number of people, like, for example, we only have 2 people in the house now versus when we had more. And I'm just curious how the benefits of avoided oil are calculated.
Well, with a hydronically heated water heater, your system is going to keep that 50 gallons hot all the time, regardless of who's in the house.
Right, but it's a
So-
superstore. It's one of those superstore hot water things that's quite insulated. And I can't even tell if might have put on parts of it a little bit more. So it doesn't run very much. But no, I think it probably will make sense. I'm just curious
Yeah.
whether it deals with the number of people in the house.
Yeah, so the answer, Michael, is it's not based off the number of people. It's based off the Energy Star rating, which itself is based off some average number of people, average number of gallons of hot water used. So I use that number to feed this model rather than say there's 2 people in your house and calculate 40 gallons per person per day or something like that. But that's how I do it. So if you think you're using less than average, then your savings would be a bit smaller.
Right. I mean, it's still with the solar panels there that I oversized to deal with stuff like this. I mean, I was hoping to go to heat pumps and things that even if I cut it in half, it's still an attractive.
Yeah. Okay. So let's go to the heat pump for heating the air in the house. Now, Karen, you haven't spoken yet tonight, so you want to just take us on that one?
Yeah, what do you want to know about it?
What are your thoughts? You've got the financials here. What sort of things would you be recommending to Michael about heat pumps for heating his house?
I think it's a go because he's already got the solar set up. And at the solar rate, he's got a high NPV. Utility rates, okay.
So all these NPVs are negative. Red and brackets here means negative.
Yeah. Oh, so he shouldn't. I don't know. I need you to walk me through this one.
Okay. Anyone else got any ideas? Nicole.
Whoops. Yeah, it doesn't look like it's from the numbers. It doesn't look like it's a go at all. And I found that interesting. I thought that, Fab Four, this would have come up, especially, and then considering he does have the large system of a solar array, that'd be like, wow, then great, let's think about adding your heat pump. But according to these numbers, it doesn't make any sense at all.
Right. Anybody else got any comments on this? I think Nicole's right. I think the numbers are large and negative. Sometimes if the net present value is about 0 or slightly negative, these things aren't that precise. So
Right.
it could make sense if there's other qualitative issues, like your boiler's getting old or whatever. There are other things that might make sense, but these are very large numbers and they're very negative. So
David, I have a question here. What does it mean, like the third row, add heat pumps at extra cost versus replacing AC and utility rates? So is it a scenario where you want to add some AC here, or?
No. So the adding the heat pumps at utility rates, the first line, the second line at solar rates, means paying the full cost of the new heat pump. So something like $25,000 for a house. There's the second pair of lines, add heat pumps at extra cost versus replacing AC, is if your AC units are failing and you've already made the decision you need to replace them.
Okay, but Michael doesn't have AC in the first place.
Right, exactly. So these two lines don't really even count for Michael because he doesn't have AC.
Yeah, that was confusing to me.
But most of your clients will have AC. And quite a few of them will be coming up on replacing their AC units. A lot of people keep their AC units for 20 years, 25 years, in which case they're going to have to be replaced fairly soon. And replacing the AC unit makes it a lot cheaper because if you have to replace the AC unit, that's $15,000 just to replace the AC. We're spending an extra $10,000 to get a heat pump that is going to do the AC in summer and heat in the wintertime. Becomes much, much more cost effective because it's only $10,000 now, not $25,000. To buy the heat pump. That's what that means at the bottom. Okay.
Yeah, got it.
But you can see even at just the incremental cost of a heat pump over the cost of a AC unit, and at the solar rate, which is lower than the utility rate, the net present value is still negative. Now, has anyone got any ideas as to why this might be the case? because you're right. For most people, these will not be the answers you'll get from most people. But why is Michael's house? People just
Maybe
say-
because it's so much tighter than because it was just built. It was built recently, so it's better insulated. He has the best windows that he could get at the time. So it's a better built house than, say, something built previous to that.
And his wife doesn't mind a 65-degree set point.
Right, I think that's part of it.
That's part of it.
So your delta T is not an issue.
Exactly. So I think both those points are valid. I think Scott's point is probably the bigger cause of it. That Michael keeps his house relatively cold. I'm not making a value judgment. You can keep your house at whatever temperature you want. But those who do keep it colder have much less heating need, hence much lower heating bills. And so the amount of money you can save by being more efficient at heating less. And that combined with what Cindy said, it's a relatively new house. So it's a little bit tighter than, say, is it Karen's or no, Cindy's, sorry, is very, Cindy's is much draftier. So Michael's house is not bad. And it's got those 2x6 walls filled with insulation. So it's not bad. And because his energy use is relatively low, it's not super low, but it's lower than normal. The cost saving from putting in a heat pump is less than would be on an average house. So it's all these things combined come to make it pretty expensive for Michael. Not a very good financial decision to put in a heat pump for heating the house, in contrast to the heat pump for the hot water, which is a very good decision. So I hope this starts to show you how we can use the financial analysis to get us to which things should we do and which things should we not do, and which things are within those things we should do, those with the positive net present values, which ones to be prioritized first. So if you look at the insulation compared to, say, the heat pump or water tank, they both have positive NPVs, so they're both things we should do. And the insulation has a much higher IRR than the heat pump or water tank does, at 68% versus 38%. But still, these are both very good IRRs. I mean, no one could complain about even a 38% IRR. So to me, these are kind of slam dunks. These are the two things that make, they're relatively short money, going to make a big difference to Michael's budget and to the comfort of his home, because the insulation will make the house more comfortable, and the heat pump or water tank will hopefully dehumidify his basement. But if it doesn't, his worst case scenario is keep the dehumidifier.
Quick question.
Yeah.
The $25,000 7-year no interest loan is eligible for heat pump and heat pump hot water heater both, but nothing else?
So yes, it's for both. It's actually more than just those two. You can also get triple glazed windows financed using the 0% interest heat loan. Now there are restrictions on that.
You have to be replacing single glazed.
Right. So Michael wouldn't be able to use that because he
No,
has
he's
double
because
glazed.
he's got double glazed.
Yeah.
Right.
So, and that's often going to be the case. I mean, some people do still have single glazed windows. I had some in my house. So you are going to come across this, but it's much harder to meet the jump through all the hoops to do windows on the heat loan. And for most people, they're going to be putting in a heat pump anyway, in which case they're going to be using up most of that heat loan to put in the heat pump. And that is the better way to use the heat loan rather than using it to put in triple glazed windows, because you're going to get a bigger bang for your buck on the heat pump than you would on the windows. Okay, let's just keep going then. So what about the—
So I don't think he should do his windows. When I was looking at the numbers for his windows, it doesn't make any sense. I mean, he has double glazed windows and it doesn't, the numbers, the financials don't show it to be a benefit to go to triple glazed.
Okay, and just to walk us through, Cindy, how you reached that conclusion. I agree with you, but just walk us through how you reached that.
All right, I hopefully you can still see me, I think, even though I can't see you. But as I'm looking at this, how do I come up with that? Well, adding triple glazed windows at full cost of installation is almost $200,000.
Yep.
He has a negative IRR and he has a negative NPV. He doesn't, I see the second line is adding the triple glazed windows. If you were going to already change out your windows to, like it's just the incremental cost above the double glazed.
Yep.
Right. But he's not doing that because he already has the double glaze in place. So it's not, that second line doesn't even apply to him. And then adding the inner glass window insert, it still shows a negative IRR and a negative MPV. So it just doesn't make any sense. He's not getting a very big bang for his buck at all on the windows aspect.
Now, does anyone disagree with Cindy? No, Katie's voting for you, Cindy. Nicole's voting.
Oh, good, thank you.
Scott's voting for you. Dorothy, what do you think?
I think so too.
So I think we have a clean sweep there. So
I would only comment that it's not even a matter of I'm not getting much of a bang for the buck. I'm not getting any bang for the buck.
yeah, negative.
I'm throwing money away in terms
You're
of
throwing money away.
in terms of how you might describe it to somebody.
And since your windows are relatively new, it's not like they're 30 years old and they're going to need replacing at some point. So I think I completely agree with what you've all said, which is this doesn't make sense. The only sort of little asterisk I might put on it is, Michael, in the future, when your windows do need replacing, and they will eventually, just not now, then think about triple glaze rather than double glaze. But this is way ahead in your future, so it's really.
Oh yeah, no, I looked at it back then, and it was back then the costs were a little bit. Now the price has come down tremendously compared to back then. So I would, if I was doing it today, and I would say as the analysis shows that for anybody who's even at all thinking about replacing the windows, they should really look at the triple pane, and it's the kind of thing we're trying to even push. I mean, it'd be nice if we could push the big project in town to do it too.
Yeah, it would be.
But and supposedly the costs have come down a lot, but it's just not quite there.
Yeah. Okay, let's move
And
on.
maybe by the time you have to replace yours, Michael, we'll have quadruple pane.
No, I mean, Cindy, you laugh, but you can buy them in Europe. There are very high-end, very expensive manufacturers who make quad pane and even quintuple pane windows. I think the extra cost is getting to be insane compared to the extra savings.
What's next is vacuum glazing.
Yeah, there's all kinds.
Or a PV film inside, so it's generating electricity while
Yeah. All right,
thing.
let's stick to what we're doing tonight. So let's talk about solar panels. It's a very important one for Michael. Now, remember what I've done here is I've taken out his existing solar panel array from the base numbers and then looked at if he wants to go zero on this house, in other words, generate all of the electricity he needs to run everything, including the heat pump hot water tank, and also assuming he adds one EV, because he said that in the questionnaire. He wants to add an EV or is thinking about adding an EV in the future. So I've included that in the analysis. And the size of the array that's spat out here is the size of the array that will allow him to get to a zero carbon footprint on his house and the EV and the heat pump hot water tank.
That's the size of your array, isn't it, Michael? 7?
Yes. Yeah. I'm a little surprised. I guess it depends how many miles you're putting in for the electric car to go on. Yes. That's what
and remember, your house is reasonably energy efficient, Michael, and you keep it fairly cold. So the heating load on your house is just not huge.
Right.
And with the extra insulation, and there's an extra 14 inches of cellulose in the attic, 12 inches in the ceiling of the basement, that's going to reduce your heating load even further. So so the amount of additional energy you need to power everything with all those changes is not that big.
Right, but how much electricity do you say would go to to the heat pump or to an electric car, like in this work?
So for let's take it one by one. So for the heat pump, it's very easy. I assume the average year-round COP, which is about 2.5 in our neck of the woods, and then calculate the amount of electricity needed to generate the same amount of heat you're generating today. Actually, the same amount of heat after you've done the insulation.
I'm talking about for the hot water heater.
For the hot water heater, that's just using the same number in both cases. It's the it's the amount of hot water that is recommended as the.
Yeah, I'm just wondering how much is or do you know, or you can't see it, like you're having me. This thing generates 7,690 kilowatt hours per year. There, I use about half of that now or less. But I'm just wondering how much hot water, whether you have it at your hand, how much would go to a car and how much would go to the hot water heat pump.
I don't have it in my hand, Michael,
Okay.
but I do have those answers, so I can certainly look that up for you. I don't remember off the top of my head. I think the car is probably using about half of this. I'm guessing.
Oh, okay.
Because 10,000 miles a year is about 3,000 kilowatt hours, and this is a 7,000 kilowatt hour a year array. So about half of this is going for the car.
Okay.
And
Quick question,
yeah, go ahead.
quick question, David. As I'm looking between column, the left column and the right column, on your gross installed cost array only, it's 19,000. And on your gross installed cost array plus battery, it's 39,000.
Mhm.
It's $20,000 for the battery?
Yeah.
That is correct.
How big a battery are you putting in there?
Wow, I had no idea.
Because the cost was less, I was quoted a lot less than that when it depends how many kilowatt, if it's whole house backup or not, but.
Yeah, so my assumption here is actually the same as what I'm doing on my house, which is installing a single 10 kilowatt hour Sonnen battery. Now the Tesla Powerwall battery is cheaper per kilowatt hour storage, but you can't get them. That's the problem. So if Michael was prepared to wait until Elon Musk will allow people to buy his batteries, then he could do this much cheaper. But that will probably be at least 6 months from now, at which point the battery adder under the smart program will be less, as will the array the array subsidy under smart. So there's a tension there which I have resolved myself by saying I'm not waiting for the Tesla Powerwall, even though it's cheaper, because the net present value to me of buying the Sonnen battery, which is much higher, is still positive today. And I know that sometime in the future, say 6 months from now, even a year from now, before you can buy that Tesla Powerwall battery, I know the subsidies will be lower. I don't know how much lower, but I know they're going to be lower. So it's not easy to be definitive on this one, Michael. It's more of a judgment call as to whether you want to go with a more expensive battery today and get the higher subsidies, or wait and probably get lower subsidies but get a cheaper battery.
All I'll say to you is that I was quoted for a 12 kilowatt hour system. The Generac was $14,000.
For how many kilowatt hours?
12.
12. So there's two Sonnen batteries here at 10 kilowatts. So 10 kilowatt hours. It's a 20 kilowatt hour system.
Oh, okay. If it's going to be that much.
I think.
Okay. If you're going to go that high, then I could see why it's 20,000.
Yeah.
And right. And you could see that like I look at it and I say, wow, the IRR goes down to 9%.
Yeah.
Which might mean that on the, if I just looked at the battery, whether I'm not sure it would have a positive IRR if the IRR drops from 18 to 9. So I would look, like I looked on the margin, and it basically does barely break even, or it is a little negative when I looked at it. Which
no, that's exactly right, Michael. That because the IRR goes down by adding the battery, it is costing you money. Now it's still heavily subsidized, but nevertheless, and you're still making a 9% IRR, which is not a bad rate of return on your investment in the battery and the solar panel array. So it's not like you're wasting money.
but I guess, then here, this is why, as a client, I would say, well, on the margin, if I just looked at the battery alone, I could believe that might be negative. Just even though the 9% for the package is all right, but I could believe that if I just looked at the battery, it would be a negative IRR in net present value. So it wouldn't be worth it for me to do it.
18% to 9%.
What's that?
You're moving from 18% to 9%.
Yeah.
Right, but the difference on the margin is if I just looked at the difference between them, I'm sending an extra $20,000, and if I looked at what the IRR is on that 20,000, I would think that the IRR on that 20,000 is going to be negative because it's dropping it so far down.
I think you're right, Michael. So I think a battery is, you could do it if you wanted to. It's not going to kill you. You're going to make a good return doing it, but you'll make a much better return doing the solar panel array only. So it's really a case of how much do you value having the uninterruptibility of your current electricity supply, and is that worth spending some more money? And if it's not worth the getting a 9% IRR compared to 18, then just go with the solar panel array. You can always add the battery later. It's
exactly what I've done. I did this analysis and decided that the battery was on the margin was negative.
Yep.
And I'm waiting to see whether the battery costs come down.
Yeah.
And then I'll do it later. But no, I'm just trying to think of what it means to tell clients to that you can get an IRR of 9 when the battery really is, I mean, I guess it's a tricky issue of the battery is really costing you money to do this. And obviously it gets tricky because you could put in for $20,000, you could put in a whole house Generac system for, I don't know, $5,000 or $7,000. That's auto starting and you just have to have propane and who knows what so that I can't tell if I feel that looking at it as a whole in that right-hand column, I feel a little uncomfortable that that's the way I would want to present to somebody, that it's still a positive IRR with a battery versus it's really not attractive to put in a battery.
Well, Michael, we could have a longer discussion about IRRs and net present values, but if the IRR is greater than, if the net present value is positive and the IRR sounds good, it's still a good investment for you.
I guess we will have to talk about this separately.
Okay, but let's just leave that then, because I think overall, Michael I can't argue with his decision to go with a solar panel array and not get a battery, or defer getting a battery until such time as the economics make sense for him. And they may do. It may be that a year from now, Tesla is able to deliver Powerwall batteries, which are much cheaper than Sonnen batteries per kilowatt hour, and maybe the subsidies won't have fallen that much. It still makes good sense. So I can't argue with what Michael is concluding. And if he wants to put in an additional solar panel array, I think if you've got the space on the roof, this is what I couldn't really determine, Michael, because you've got 7 kW already, maybe that's in the best place on the roof. And maybe there isn't enough room to get an additional 7 kW. So that was something I couldn't really figure out from this. But I certainly think looking at an additional solar panel array makes far more economic sense than the array and the battery.
Mhm. Right. No, this is using the best space on the roof, filling up the best space. But there are other spaces, but it gets more marginal.
Yeah. Okay. Okay. So and just the last thing I made comments on about the appliances is because the fridge and the freezer are pretty old. 15 years is kind of around the time when it would make economic sense to replace them. I just put in a note saying that consider replacing the fridge or the freezer. A new one is likely to pay for itself within a few years, but without doing that actual calculation, Michael, on what the label on your current fridge says,
Right.
it's pretty easy to do because you can look at the
Oh, yeah, no, that's what I'm going to go do now. I'll go look at that label versus a label in a store or online for a new Energy Star, and I can see how much I could save in a year.
How much it just multiply it by 23 cents a kilowatt hour, and then you got your number. So it's
right. No, that's what I plan to do.
It's very easy to do. Okay, so it's taken us.
Get the new fridge, Michael. Get the new fridge.
I'll let you know how it goes, everybody.
Will you get ice and water on the door? That's the question.
No, we decided not to do that the first time and not again.
So Michael, when I bought the new fridge, I did not get the ice and water on the door because I spoke with the repair guys, and almost all of their repair are to do with the door, the ice and water system, not to do with the fridge itself or the freezer itself. Those are very reliable, but the through the door water and ice stuff causes all the problems. So we just went with a plain one that had nothing.
But it limits your availability of what you can buy. I remember that last time. We didn't want to do it, and I was shocked at how few choices I had.
You can get it with an ice maker.
I mean, we just shut ours off. We couldn't get one without an ice maker, but then we just didn't make ice.
Yep. Good call, Fred. Okay, so I was actually planning on doing at least 2 of these tonight, and maybe even 3. Right? So we're clearly not going to be able to do that. So rather than go through the other ones, let me just sort of to take a pause for a minute, because I was originally planning to do the assessment for next week. But let's remember, the whole purpose of this is for you guys to get to that level of confidence where you feel able to consult the clients. And I don't care whether it takes 1 week, 2 weeks, 3 weeks, 4 weeks, it doesn't matter. I'll stay with you and keep discussing it and keep going through examples like this until you feel confident. I don't want to be rushed into this or feel, yeah, Michael?
I was going to just ask, it's 8:45 and we took that. I mean, is it even an option to put off next week assessment and just put off continuing and doing 2 more houses and talking them through more next week before the final session, so people just get more comfortable with
I would go for that.
through that.
That's what I'm sort of asking. I'm seeing a
Yeah.
lot of heads nodding that
Yeah,
you really want some more examples of working through them.
yeah.
Okay.
I would do the next 2 houses next week, maybe, if we can get through 2.
But I mean, to me, every question is learning.
Oh,
Right.
yeah.
Every time something comes up, you got to deal with it. It's building your knowledge so that when you do see a new client for the first time, and you have this beside you, you'll have the client questionnaire, you'll have the outputs. You feel more confident in giving your advice. So now, Scott, you were not nodding your head.
No.
You were, okay. Dorothea? All right. Karen? Okay, and Fred too. Okay,
I'm fine, but I got to learn more about the financials. I got to rewatch the video or something because
You're not alone.
it's not my forte. Yeah.
I also had a question on a couple of things, but one is on that came up with this on batteries. And I don't think I'm understanding completely what batteries do. I was under the impression that's just if when the power goes out, it's like a generator.
that's exactly right, Nicole.
Is it also some way to store what you've produced, even if you produced more? I mean, does it kind of override the net metering thing at all, or?
So in theory, Nicole, you can do exactly that. You can store energy during the day and release it at night, but there's no point.
There isn't.
Because that's going off grid, right? If you go off grid, you're out in a cabin in Maine somewhere. Yes, you want to make the electricity during the day, charge up your batteries, and run the house overnight on those batteries. But we have grid connections here. We have net metering. Nobody is ever going to be cutting off their electrical supply when they put in solar panels, even if they've got a battery.
There's no financial benefit to using your own stored than buying it from.
None whatsoever. None whatsoever. Now, that is not always true, Nicole. It is always true in Massachusetts because we do not have an electrical tariff that is time of day. Other places do, and you get charged more for electricity during the day than you do at night. In which case, doing what you suggest, storing your battery, charging your battery at night and discharging it to run your house during the day makes sense because you can buy electricity cheap and use it during the day. But we don't have a time of day tariff in Massachusetts. So it's kind of a moot point here. But in other parts of the country where they do, then you can use a battery to do that. But for us around here, batteries are really an alternative to a backup generator, like a diesel generator or propane generator.
And it wouldn't do anything for your electric vehicles, is like storing something there to use for them later. It's just as like a generator.
That's all it is. It's a backup generator for you.
So, David, help me out here. If I store a bunch of electricity in my battery during the day, you're saying I can't charge my car at night?
You can.
But you can, Fred. You can do all of the above. But the cost to you is going to be the same because when you use that kilowatt hour of electricity, whether it's to run your house or to charge your car at night, you're paying 23 cents. So it doesn't matter whether you use that solar power during the day or whether you use it during the night.
Okay.
So this is kind of a common misunderstanding because a lot of people read stuff about using a battery to store your solar electricity during the day and charge your car or just charge your house or run your house at night. But where we are, it doesn't make any difference. It does in other places in the country, but not here.
Can I ask a question?
Go ahead, Cindy.
So but if you are, say, like with your situation, if you're like loading tons of kilowatt hours, you're getting so many during the day that you're able to send it out to the grid, and then you need to use the grid at night to run your electrical things, to power your electrical things. You're actually, though, not having to pay that 23 cents an hour at night because you fed so much into the grid during the day. Is that right?
Yes.
Did I understand that right?
It's like a bank account, Cindy. You pay in dollars into the bank account during the day and you build up a stack. and then at night you draw that stack down. But it's a credit, and what happens over the course of the summertime is you build up a lot of credit, thousands of kilowatt hours over the summertime, and then I don't really draw those down and don't finish drawing those down until about March, because there's so much built up over the summertime. Even when my heat pumps start heating the house in October, November, December, January, February, I'm drawing down those kilowatt hours, but I don't get to a zero balance until about March, when the sun is starting to be strong enough, it recharges my bank account during the summer for the next year, and it goes down again later in the year. So in effect, Eversource and net metering is becoming your backup generator.
Thank you.
Does
I
that
have
make
a
sense,
question.
James?
Yeah, thank you.
It did, okay.
Same, I was reading your, it said the battery was an adder of 4 kilowatts. I didn't understand that.
I didn't hear you, Katie. Can you just say it again?
The cheat sheet said the battery is a adder of 4 kilowatt hours. I didn't understand that.
So when you install solar panels today, the biggest subsidy is the federal tax credit, which is 26% of the cost of the array. The second biggest subsidy is the Massachusetts SMART subsidy, and that subsidizes the array, and the current rate is about 8 cents per kilowatt hour generated by the array. So a 10 kW array will generate about 10,000 kilowatt hours per year. At 8 cents per kilowatt hour is about $800 per year. Okay, that's the subsidy, the state subsidy for the array. If you buy a battery at the same time as the solar panels, the state gives you an extra 4 cents per kilowatt hour. So instead of getting 8 cents, you now get 12 cents. That's why it's called an adder. It's added on to the basic
Okay.
rate.
Mm-hmm.
And there are actually several other adders as well. So someone, I think it was Nicole, is a legal farm. Is that right? Yeah. So so if you're a legal farm in Massachusetts, there's an additional adder you can get for having solar panels over a field where you're still using the field for agriculture.
Yeah, I think I looked it up because I was like, yay, but I'm not a commercial producer at it has to be a commercial, like a major farm. I'm not there.
I don't think so, actually, Nicole, but let's not argue about it here. But I actually think as long as you're a Chapter 61A farm, you can take advantage of the canopy. But let's leave that to the side. There are other adders too. If you're low income, there's an adder for low income. There's quite a few of these different adders that can all be added up together to make your subsidy much higher. They're all based off having a solar panel array first, and that gives you a basic rate of about 8 cents per kilowatt hour. And then you get these adders on top based off things like low income, farm status, batteries, all kinds of things. But by far the biggest one you'll come across, because not many people in Sherburne are low income, by far the most common one you're going to come across is the battery.
And this is the SMART reimbursement, so it's 10 years.
It's 10 years, that's right. It's so the SMART rates, the 8 cents for the battery, the 8 cents for the solar panels, the 4 cents for the battery, those numbers decline with time. But the date you get yours, that rate is set for 10 years. So if you put in a solar panel array with a battery today, you will get 8 cents per kilowatt hour for 10 years for the array and 4 cents per kilowatt hour for 10 years for the battery. But if you were to wait a year, that might be 7 cents per kilowatt hour for the array and 3.5 cents for the battery. Because the nature of the program is these things step down over time.
Last question in regards of battery. Is that the program where you basically allow for a demand control? So that's why they're giving you that adder, right?
Now, there's two separate subsidies, Dorothea.
Okay.
So the first one is the SMART subsidy, which comes from the state, is paid through Eversource, but it comes from the state. And that is the 8 cents per kilowatt hour for the array and for the electricity produced by the array, and an adder of 4 cents for the battery.
Yeah.
In addition to that, a totally separate scheme run by Eversource, not run by the state, is the Connected Solutions program.
Okay, so but that's not in here, right?
Yes, it is. So you'll see if you look at the lines here, it says on the left-hand side, solar panel financial summary without battery, NPV smart array only after tax, net cost after FTC, the federal tax credit, STC, the state tax credit, NPV of smart. Oh, I'm sorry, you've got to look at the other side. Because with the battery, that line changes to net cost after FTC, federal tax credit, STC, state tax credit, NP of smart, array plus battery adder, okay?
Mhm.
CS stands for Connected Solutions.
Okay, here we
Yeah,
go. So, yeah,
the Eversource program, which pays to rent your battery
yeah,
during the peak times on the grid. And that subsidy is quite significant.
exactly. I just wanted to say, how does that compare to the smart battery adder?
It's at least as much, and it can be 50% more.
Okay,
So it's quite significant, the Connected Solutions payment. And in fact, the batteries I'm planning to install in the next few months, the Connected Solutions, they will all be enrolled in Connected Solutions to get that extra subsidy. And it's quite significant. Without that Connected Solutions subsidy, they would be much more marginal. Now, mine all have positive IRRs, they're all positive net present values, so I'm going to be doing it because they're good investments, even with the Sonnen battery, rather than waiting for the
right.
Tesla Powerwall battery later in the year, if they ever do it. But because of that additional subsidy from the Connected Solutions programs, it brings down the net investment quite substantially.
Yeah.
And it raises the IRR and the net present value quite substantially. Without the Connected Solutions, they would probably not make financial sense.
I would say, I looked at it, when I looked at it, it almost paid for half the battery cost.
Yeah, exactly.
Just that alone. And I'll say, even though it's an incentive, I'll be a little political and say, in a form, it's not necessarily a subsidy. It's basically, it's allowing the grid,
Yep,
when
correct.
it has peak electricity demands, when normally you have to use very expensive electricity that's often carbon-based, sort of these peaker plants that are expensive and not the most efficient. This is crafted so that they will use your battery to shave the peak, as it's called, to lessen, to meet the demand, the peak demand for electricity. So it's basically, could be, I mean, I haven't quite done it to see how, if what they pay us is equal to what they avoid in the cost, but the whole idea is to basically, it might actually lower the whole cost of the system and your electricity supply to do it. And in the future, there's smart grids where they might even, you have your car plugged in and you let your car battery to be used as to shave the peak. And so there's a lot of really interesting smart grid options that will cut the cost of electricity and the peak. But it is the Connected Solutions, I'm curious your experience. When I looked into it, you have to it seemed a little hard to know that you could actually enroll for sure when I called them, that it was like, and it's a summer and a winter peak. And they said, well, we're not sure, we might fill up. And I was like, oh, so I'm going to go buy a battery, but I can't tell if I'm going to get this payment. And I couldn't get that lined up in time. So I didn't do it, but I'm hoping that they're going to be a little more straightforward about.
When was that, Michael?
That was back in November. Maybe that was November or October.
So I agree with you that Eversource has been very evasive about how much you're actually going to get paid and when and for how many years. So for now, the program is only scheduled to be for 5 years. But if you read the writing on the wall, once something is by law included in an electrical tariff, it is almost impossible to get it out.
Yeah, but I'm not sure this is part of the tariff, but we could talk about it. But hopefully it'll be easier for you to know that you have it ahead of time, that you're enrolled, versus the fact that you arranged to have a battery put in because they said, we might be filled up in the wintertime, because there's a payment for the summer and for the winter, 2 separate payments. So hopefully the regulators will fix up Eversource so that they basically have a much more transparent and clear-cut process. But you'll see what you find, David. I'm going to look into it again.
Yeah. Okay. Scott.
How do we find the kilowatt hours per year number?
For what?
Well, we've got on Michael's is 7690 at 7 kW. And then Cindy's is 131113 at 16 kW.
So that's based off the sun number, and if
Yeah.
you've got it, the Google Project Sunroof numbers as well. I've built little translation tables to translate the Google numbers and the sun number numbers into how many kilowatt hours you're going to produce per watt of power. So they're
Okay.
not exact; they're kind of rough numbers, but they get you into to essentially allowing for the shade on your roof and the orientation of your roof towards the sun.
So that sun number is used as a multiplier?
No, it's not. It's not a one-to-one. You can't use it in a calculation. I just use
Okay.
it to correlate to the cost per kilowatt hour that I've experienced on arrays where I know what the sun number is. I know what the Google net present value is, the Project Sunroof number is, and I know what the cost per kilowatt hour is. So I've used it as sort of calibration points to get a rough number as to how many kilowatt hours per year you're going to get per kilowatt of installed power.
Mm-hmm.
And when it comes down to actually doing it, the installers come out and they will all give you estimates up front, and they use their own analysis, like when you even go to get bids or first level bids from Energy Sage, let's say, which is an online service where you can say, have suppliers give me offers for what it would cost to put on my roof. And they all do their estimates online, and sometimes they come out and stand on your roof and do that kind of calculation, which is what they did in mine. Like in my case, however you got, whatever number you got there, they gave me a little bit higher estimate of what I might get from my system. But yeah, and they vary differently, and they will often, if you get the right, they'll often guarantee a certain amount. If the company is around long enough, then you can do that.
While you're on that topic, how long do you think is reasonable to wait for Energy Sage to get back to you?
My experience has been very quick. What's been the problem, Cindy?
I contacted them. I submitted my information. They got back to me because they felt like the pin wasn't right on my rooftop. So they sent me something showing me where they moved the pin to, which was from the woods to my rooftop. And I said, yes, this is accurate. That was 2 weeks ago, and I still haven't heard anything from them.
I guess nobody likes your roof because they sell.
I don't think they do.
The suppliers, installers pay about $100, or they have to pay a fee to buy it, and then they can give a quote. Then they basically sell the information to a set of approved suppliers. And so it's where the suppliers have either too much business because they're full, or this or that, or how eager they are to do that. Not everybody uses it, but.
Right, but Cindy's question is a bit different. You're not at the stage of getting bids yet. You're just at the stage of getting a correct response from the Energy Sage website.
Well, right. So I input all of my information that they wanted. And then they said that the next, step would be that I would hear from basically quotes. I'd hear from
people at that stage that I was talking about.
Okay, all right, okay.
No, they either.
So they must not like my roof.
Yeah, maybe. So if Energy Sage doesn't work like that, Cindy, then you can still just contact installers directly. So that, I think, would be your next step. And sometimes nobody bids on the project. It may be that people don't like your project, or they're just too busy, like Michael was saying. So sometimes you just have to go with that approach, and sometimes you just have to go around it. And so at this point, with 2 weeks, I would just say, well, yeah, let's just call some people, and I can give you some recommendations, and probably other people can give you recommendations too. Okay, guys, it's 9:03. So what I suggest we do then is, given everyone was nodding, is we do the same thing next week, and we'll go with who's next on the list. I forget. Cindy's, I think, is next on the list. In the next week, I will complete the rest of the energy modeling, so we have a complete set for everyone.
Oh, super. May I just say that I'm also thinking about a battery for my house.
Okay, well, hopefully by next week, Dorothy, I'll have all the energy modeling done. And just so you know, it took a week to do the first one.
Oh boy.
And then that was Cindy's house, I think, was the first one. And then it took me a day to do Michael's, that was the second one. And no, I'm sorry, Nicole's was the first one. That took a week. Michael's took a day, and Cindy took me 4 hours. So hopefully we're going in the right direction. They'll get smoother and smoother over time.
Sorry about that.
That's okay. No, I'm not blaming you. It's just that there was so much I needed to change.
It's the development of the program.
Exactly. Yeah, exactly. So no, there's no need to apologize. It wasn't your mistake or anything. It's just that there was new stuff in your
Yeah.
data that I needed to accommodate in the model. That's all.
And I'm sure he had lots of fun doing it.
Oh, absolutely.
Actually, he's thanking you for that.
My device is
Thank you for the
fine.
challenge, Nicole. Thank you.
And I'm gonna, as soon as I get off here, I'm gonna run downstairs and see if I could find the little
Refrigerator.
refrigerator.
All right, so I'll see you next week, and hopefully by then I'll get you additional models. But we'll start with the 2 I've already sent you, and see if we can get through those and see what we can learn from those ones.
Sounds good.
Okay.
Great,
Sounds
thank you,
good.
David.
Great work,
Everyone.
David.
David.
Fantastic.
Good night, everybody.
Bye.
Good night.
Bye.